Hello guys, today we're going to walk through this problem that has 4 parts, and it's about acceleration and displacement. So let's start with part A. What constant acceleration in SI units must a car have to go from 0 to 60 miles per hour in 10 seconds? Express your answer in meters per second square. Since we have to use the International System of Units, we are going to convert miles per hour to meters per second. We know that 1 hour it's equivalent to 3600 seconds. That's why I multiply that factor and we see how hours with hours cancel out. The same way we know that 1609 meters are 1 mile. That's why as those are equivalent, I multiply that factor and we see how miles with miles cancel out, leaving us with an answer of 26.822 meters per second that is in the International System of Units. That's what we need. Now that we have the velocity in meters per second, let's think about the acceleration. We know that this velocity that we just found is the final velocity, because we know that in the problem they say that the car goes from 0 to 60 miles per hour, that in meters per second is 26.8. We know that the average acceleration by definition, it's the rate of change of velocity with respect to time. We say it's delta v over delta t. So we could say that v final minus v initial is 26.82 minus 0 over t final minus t initial. T final is 10 seconds, and the initial moment when the experiment started is 0. So it's 10 minus 0. And we got that the acceleration, for this case, is 2.68 meters per second square. We round up to 2.7 meters per second square, and we found that this is correct. Now part B. What fraction of g is this? Express your answer in terms of g. We know that the acceleration of gravity, g, is approximately 9.8 meters per second square at sea level. We want to know what fraction of that g is the acceleration that we found. That means that we have to calculate a over g. The acceleration that we found, and we divide by 9.8, finding a ratio of 0.276. And we can round up to 0.28 g. That's the fraction of g that corresponds to the acceleration that we found for this car. Now let's do part C. How far has the car traveled when it reaches 60 miles per hour? Give your answer in SI units. Express your answer in meters. So we know that it starts covering a distance in meters. It's going in one direction, and by the moment it hits the 60 miles per hour or 26.8 meters per second, it has already covered the distance. We want to know how far the car went from the beginning to the end of 10 seconds. We can see on the screen a graph of velocity in meters per second against time in seconds. The y-axis is velocity and the x-axis is time. It is noted 26.8 meters per second is the max velocity, and 10 seconds is going to be the time that it took to the car to reach to that velocity. Now that we have this graph in mind and we see that the acceleration is constant, let's analyze this case with kinematic equations. We know that v final square is equal to v initial square plus 2 times the acceleration times delta x. The final velocity is 26.82. The initial velocity is equal to 0 from the givens, plus 2 times 2.68, that's the acceleration that we found in the first part of this problem. Now the only unknown that we have is delta x. Let's do some algebra to solve for delta x. We divide and we find that delta x is 134.2 meters. This is the displacement that the car had from the beginning in time 0 seconds to the end time 10 seconds. Just to double check our answer, let's find the displacement as the area below the curve of this velocity versus time graph. You see that the area is now in orange, and that represents delta x, the displacement of the car from the beginning to the end. We know that the area of a triangle is 1/2 times the base times the height. In this case, delta x would be 1/2 of 10 seconds, that's the base, multiplied by 26.8 meters per second, that's the height of the triangle. we see that seconds with seconds cancel out, and we get to delta x, it's equal to 134.1 meters. That's really close to the answer that we got before with the kinematic equations, and we can see that we got the same answer from two different ways. Now, let's do part D. How far had the car traveled in feet? We found from part C that delta x is 134.2 meters. The conversion factor for 1 meter it's 3.28084 feet. Now that's why I multiplied that factor. We see how meters with meters cancel out, and we get an answer of 440.3 feet. We round down to 440 feet, and we see that this is correct. This is only applying the conversion factor to the answer that we already got from part C. Okay guys, I hope that this video was useful. Remember to like if you like it, to hit that subscribe button, and to share this video with your friends, your geek friends, your cat, your dog, your bird, your girlfriend, and with anyone who needs physics for college or life. I'll see you in the next video, and keep it going guys.